Hi, I'm Trick from Faculty of Mechanical Engineering and welcome back to the course. In this video, I will introduce to you a counter and timer in a microcontrollers, a PIC microcontrollers. So this is a block diagrams of timer zeros. In the microcontrollers, a timer or counter hardware modules is the modules help us counting the event, or it help us measure the times, the amount of time for an event. So in the block diagram, we will see from the left to the right. This is the oscillators. The system oscillator is divided by 4. The timer or a counter is basically a register in a RAMs. So we have a pulse. Okay, we submit a pulse to the a register here. It will increase or by 1. Alright, it will increase by 1 to a timer or counter register values. Okay, for example, we create one pulse and supply it to the RAMs, a timer. It will increase from 0 to 1. Alright, and then we create one more pulse. The RAMs, the timer or counter will increase one more time from 1 to 2, and then one more pulse will make it to 3, and then one more pulse to 4 and 5, and so on. So that basically is the machine that increase a value for a RAMs register. So in order to generate the pulse, we have two types. Whether you use the system oscillators, okay, you use system oscillator here, it will count the times for some event or something. Is the amount of time of something happens, okay? Or you can choose to count a pulse generated in a pins of the microcontroller. In this case, is the timer 0 clock input pins. Okay, you can see that the pins at the pin maps. For example, I open the pin diagrams. Okay, let's check for the T0 and clock input is the 17. All right, it's the 17th. Is located right here. This one. This is the input pin for the counter zeros. All right. Then before you count the clock source for the timers, we have the programmable prescaler. The prescaler is something that you multiply the pulse. For example, is the input pulse here 1, 2, 3, 4, 5, and so on. If you set the prescaler for 1 to 2, for example, then 2 pulse at the input will generate 1 pulse at the output of the prescaler. So it reduce or it increase the amount of times or the amount of events created at the input and generated to the output. Okay, that's it. Look at the timer or counter more carefully. You will see that the system clocks 1, 2, 3, 4. 4 pulls at the crystal will create 1 pulse for the timer. We call it the timer and counter clocks. Okay. Then when you start the timers by setting some RAMs register from 0 to 1, then it will wait 2 circles. Okay, you have 2 circles here for synchronize, and then it will increase every clock's input at the timers modules. Okay, to 0 to 1 and 2 and 3 and 4 and 5. Okay, and so on. And at the end of the increment, for example, we have the timer 1, which is 16 bit, which is the maximum value would be FF and FF. All right, then you generate one more pulse, it will somehow reset it to 0, 0, 0. Okay, and this event, they call it the overflow. Okay, so when we have the overflow event, one bit of ARAMs, we call it the interrupt flag. The flag will set it to high. All right, so if you want to measure an event or the amount of times, you check for the flag whether it is set it or not. If it is set, then this means you have a overflow event occurs. All right, so for programming using the timers or counter, we would set the starting number. Okay, and then the stop number would be checking for the interrupt flag. From the starting number up to the overflow event, you would have the last number, that's the B, is for the maximum of the timers. For timer 1, you have F 16 bit, all right, F, and then F is the maximum for T1. For T0 or timer 0, you would have only 8 bit, so the maximum value would be FF, or 255. Okay, so you got the minus from B to A, you got the amount of times. Okay, so let's take an example here. I have the system frequency of 1 megahertz. Okay, and then I set the prescale for 1:1 or no prescale. Then I write the timer values for 100, for example. Then what would be the amount of times to get the timer overflow? All right, we open a software in Excel to make it. Okay, then all right. Okay, so the oscillation for 1 megahertz. All right, that would will create FOSC divide by 4 to make a circle. Okay, system circle, it take the value here, divide by 4. All right, this one, and then for one count of the timer, I call it the timer, okay, delta T0, for example, delta T, then it would be 1 over this one. Okay, we calculate it by the second. All right, and then if the delta T0 in microsecond, it would be this one, multiply with 1 million. Okay, so 4 microsecond every count of the timer zeros. All right, then we have the rescale for 1. Okay, we have a prescale for 1. Then the delta T0 after the prescale, it would be this one multiply with this. Okay, so it take we don't have it here, the prescale for 1. If, for example, we have the prescale for 2, for example, then it take 8 microsecond every count of the timers. All right, it count 2 times. All right, then we go back to the the value of the prescale. Then we have the timer value. All right, timer 0 for 100. All right, then the number of count to over to overflow. All right, the numbers of count to overflow, it would be the maximum value. All right, would be the maximum value minus to the starting values. Okay, then we'll check it again. If you check it again for the system here, it would create from the maximum value, it count one more times to make the overflow flag. Then the accurate value here would be 255 plus 1. Okay, plus 1 is the accurate. So this is the number of count. Then every count take 4 microseconds. Then we take 156 count. Then the amount of t0, okay, would be this one multiplied with 1 count. Okay, so we have here the microsecond, 624 microsecond for counting from 100 to overflow. Okay, we have it. The first example for week 9, timers calculating. All right, this one. So we go back to the example, this one. So if we have the prescale for 16, then we change the value here again. This one. All right, this is example 1, and then this is example number 2, example 1. Okay, and then this is example 2. Okay, I would like to change the color. Oops, I would like to change the colors for this. Okay, this one, and this is the example 2. So in the example 2, we have the prescale, this value change to 16. Okay, then we got the new result for 9,900 something. Okay, 84 something microseconds. Okay, then we got, if we have the other value for the timer 0 right here, then we would change it to for example 6 or something. Okay, or 100 as the requirement in the example. So we got a new result every change. All right, then in the application, if we need for example 1 millisecond for counting to the overflow, what would we choose? The rescale. Okay, so we can easily calculate it like this. So we have the same value for this one. Okay, I copied it again one more times. All right, this time I have my rescale. I have to open it, and then I check for the prescale. Where do my prescale? All right, the prescaler is 2, 4, 8, 16, 32 or something. Okay, so my new value for the prescale would be 1, 2, 4, 8, 16, 32, 65, 64, 1298 and 2256. Okay, this one. This is my rescale. All right, I might change the color. All right, that's it. This is the rescale. So I want to have the amount of time for t0 would be 1 millisecond or something. Okay, 1 millisecond, which is 1000 microseconds. Okay, then I have to make the count. Okay, then I have to calculate for the count and then the timers. Okay, the count to overflow. Count to overflow. Okay, count to overflow, this one, and then the timers. Okay, and then the timer value. All right, so for the rescaler 1, all right, then I would have this value is the amount of times divided by 1 count. All right, 1 count, no, 1 count, but after the rescaler delta t0, but after the rescaler. Okay, would be this value multiply with this one. Okay, so I make another columns. All right, this one would be this. Okay, and then the value for this. All right, so I lock it. This value is 4. Oops, this one. Okay, and then we go to the next, would be 4 microsecond. For the rescaler 2, we got 8 and 16 and 32 something. Okay, and then the count, this is the number of count, would be the amount of times divided by 1 count, the times for 1 count. Okay, this one, and then all right, and then the timer would be the maximum value 255 plus 1. Okay, and then minus the count to overflow. All right, and I got a 6 and this one. Okay, oops, oh, I forgot to lock the numbers here, this one and this one. All right, and make it again. All right, so we got here the odd number dot something. We cannot take it because the timers only count the integer. So the two value here, we have the valid value here for the resound for 1 millisecond. Okay, 1 millisecond. We take 6 for the timer with the rescaler of 1, or we take 131 with the prescaler of 2. Okay, that's how we calculate the timers. All right, for counting. Okay, for example, if we change the requirements to 10 millisecond. Okay, for example, we change to 10, then the result would be, no, we don't have it, because if we take the 99 dot something, then it's not the exact value. Okay, because the timer only take the integer, it don't take the dot something here, the float number. Okay, so in order to have the 10 millisecond, we have to either change the oscillator. For example, I take this value 32,000 something. Okay, for example, take this here, then I would got the beautiful numbers. Okay, got the new number. Oops. I change it to 1 second. Okay, 1 second would be got a good number. All right. Okay. For the programmings, it is very easy when we use the MCC. We have the similar initialize or write timers or read timers. Okay, actually it take the register here. Okay, then we have the checking for timer 0 has overflow occurs. Okay, it's actually check the interrupt flag. Okay, then let's see if we programming. We open the MCC. All right, then I choose the internal oscillator 1 megahertz. I turn off my pronoun reset and the other function I don't use, and then I click on generate. Okay, then I have my main programs. All right, the system initialize something. Then I open my device resources. I open the timer 0. Okay, double click on it, then it will open my timer 0. Then I have the easy setup here. If I want to use the prescaler, I just tick on the enable prescaler, then I select in the table, for example, then it will calculate for me one count and the maximum amount of time to overflow. All right, so for example, I take 1 2. Okay, then one count is 20 microsecond and the maximum value would be 5.12 milliseconds. Okay, if I want to have, for example, 1, all right, then it will calculate for me the timer values. All right, oops, the clock sources, the system frequency. Okay, the system frequency for 1 megahertz would be 8. Okay, and then 4 is 16, and then 8 or something. Okay, for example, we take the 1 2 here, and we want to have 1 millisecond. All right, that's it. If you want to enable the interrupt, okay, event, then you check here. Otherwise you don't need it, you just press the generate. So the new libraries, the timer 0.c and timer 0.h for the header and the libraries, you can open it up. All right, okay, we have here the initialize. Actually it writes some value to the register. All right, here we have the O value 1, 3 and 1. Okay, let's remember that we take 1, 3 and 1 for this one is 1000 1. All right, and then we take 1000. Okay, this one, this value with the rescaler 2, then we got 1 millisecond. All right, this one, and then we have the read timers. Actually it read the register and return it. The write timer, actually it write to the register. Reload, just load the values again, and check has overflow occurs, it checking the register a flag. Okay, very simple. Okay, then I would like to open my pin manager and make the port C for output. Okay, and then generate it again. Okay, then let's check for if, all right, if the timer 0 has occurred something, okay, then I would make the reload. All right, reload would make it reload for the new countings from 131. Okay, team timer run 0 assigned to this. Okay, and then I have to erase the flag. Okay, this one I have to erase it to make the overflow happens again. So erase it, and then I make my lat c bit dot lat c 0. Okay, assign to the new one, but I make the opposite or the invert. All right, this one. Okay, reload, and then reset the flag, and then I make the reverse for the last C0. Okay, let's check. Okay, to demonstrate, I already draw the circuits. I upload the code. Okay, week number timer demos. Okay. Okay, we have 2 units. All right, with 1 unit would be 0.5, 0.5. Then we got 1 millisecond. It's around 1 millisecond. It's not accurate 1 millisecond. Okay, because you have the checking commands here. You have the if. All right, it takes some time to execute it, and you have the reload. All right, and then reset the flag. Okay, and then you reverse your latch C. So it takes some time. So it's not absolutely accurate here. It takes some errors here. Can you see here? All right. So this is demonstrate for me. Take 1 millisecond. If you would like it more, then you change it to something. Okay, right here. Then you got a new value. For example, 4. All right. Then when we programs, we only need to set here. Okay, for example here, and then I need 2 milliseconds. All right. Then I generate. Okay, and then my programs will be updated to the new one. Okay, update to the new one, new value. Let's check. All right, it's also this one, but the rescaler would be 1.4. All right, then we rebuild and we recheck the code. Okay, this time is take 1 2 3 4. Okay, 4 unit. All right, 4 unit and a little. All right, with 1 unit for 0.5, then you got the result. Okay, that's a very simple demonstration for using a timer to create a pulse or the amount of times for an event. Okay, then we have here the real application. Okay, for the real application, we will measure the distance for ultrasonic sensor, the SRF04 or SRF05. So this sensor is basically work like this. It will measure the distance. Okay, measure the distance of an object placed in front of the sensor, and it's measured like this. When you use a trigger pulse, it has a trigger pins here. You create one pulse with 10 microseconds, and then you wait for the echoes pins to put highs, and then you measure the amount of times during the high value. Then you take this amount of time, divide by 58, then you got the distance in centimeters. It's very easy from the manufacturers. They calculate something for you. Actually, they have the microcontrollers in here. So we will communicate with this sensor. We're using the microcontrollers, of course. Then we take the diagrams like this. We start create the pulse 10 microseconds. Okay, we make it high and then wait and then set it low. Then we wait for the echo to go high. Okay, then if it is not, we just wait here, and it is yes, then we start the timers counting from 0. All right, then we wait for the echo to go low. Then we will got the timer, the amount of timer. Then we calculate it for the time travel. Then we stop the timers. We will have the distance by the amount of time divided by the 58. Okay, that's it. That's how we're gonna do. But we have to check for the maximum value. The maximum range here is 4 meters. Okay, so 4 meters. Max range is 4 meters. 4 meters, which is mean 400 centimeters. Okay, 400 centimeter. And the value, the equations, where is my equations here? Okay, the formula is the amount of time divided by 58. Okay, 58. So I got 400 for maximum. I would take this one for the maximum amount of time in the echo pins is echo max. Okay, would be 58 multiplied with this. Oops, assign to this. Okay, this is in microsecond. Okay, it's around 3.2 millisecond. Okay, then I have to set my timers can read this value. So open my timers again. Oh, sorry, timers again, and then this one is the maximum value. This is not good. Then I say here, okay, it's not so. This one, okay, so the maximum value here is 32 something, is greater than my calculated 23.2. Okay, 0.2. Then this is good. Okay, set it to minimal 1 to 8 or something microseconds. All right, then I create it, generate it. Okay, and let's check the hardware. The trigger RC1. So I open my pin manager, RC1 for triggers. Okay, and then the echo would be the listener, would be input. Okay, for RC2, and then generate. All right, open up my mains. Okay, I copied it the note for you. This one, save it to you, copy and paste it here. Okay, so you can review it. So I delete this one. Okay, and I declare my new variable for float a distance in centimeters equal to 0. Okay, to save the value. So I set the trigger, but I need to make a define for trigger would be large C bit dot plus C1. Okay, and then the echo for the reading, I used the port C bit dot RC2. Okay, this is my trigger and this is my echo. Alright, then trigger goes high, assigned to 1. Then delay microsecond 10. Okay, in order to use it, alright, and then trigger assigned to 0 to make it low. Okay, then now we wait by checking continuously. Alright, checking for echo equal to 1. Okay, oops, check 0. Okay, if it is right, then we do nothing. If it is wrong, then we go to the next, which means I start my timers. Okay, I load timer 0 to 0. Alright, I started, then oops, I have to somehow reset. Okay, somehow reset the flag of a timers to make sure I read the right value. Okay, equal to 0. Alright, then okay, we have it here. Then I wait for low. Okay, the echo assigned to equal to 1. Okay, if it is 1 or logic high, I would wait here, and do nothing. Alright, and if it is go low, then I would take my timer value. Okay, my timer value, my distance, okay, my distance would be the amount of times. The amount of time would be the timer. Okay, this is the counting, multiply with my value. Okay, 1, 2, and 8. Oops, sorry, 1, 2, and 8. 1, 2, 8. It is the amount of time for one count. Okay, and then I divide it by 58. Okay, let's remember this is a float value. Okay, this is a float value. Okay, take it down to make it global distance, and I have to kind of type cache for this one, float. Okay, otherwise it will make me wrong. Alright, this one, let's check it, something wrong. Okay, that's it. Then I have to make something display this value. I make a UART, of course. Okay, and I only need the transmit. Okay, then I generate it. Okay, and I declare I use my library, include my standard IO. Okay, and also I have my putchar function void to use the printf function. Okay, chart, the input charts, and we do my write programs. This one, I take this one, the write function. Okay, take it for the chart. Okay, then I print my value. Okay, a distance in centimeters equal to the value. Okay, and then I put the values here. All right. Okay, make some space, easy to read. Okay, and take some delay. Okay, example this. All right, then we check it again. Okay, this time we don't need this, the auxiliary. Okay, we need the virtual terminals. Okay, so we have the result for 50 something. We increase the distance, just only the simulated 70. Okay, it measure 70 dot something. Okay, point something. Okay, take another 40. Okay, there are some errors because the amount of times of calculating of measuring is 128. Okay, it's greater than one resolution of the sensor. The resolution here is 58. Okay, so it takes some errors for the measurement, but it's acceptable because it's the dot something centimeters. Okay, so that's it. That's the demonstrate for the timers. You have also the counter is similar, which is you have the two exercise. This one, the first one, just repeat what I have done, and then the next one would be using the counter for counting some rotary encoders. Okay, see you in next videos. Thank you very much.